Alright guys, today's goal, the learner will understand graphs of tangent, cotangent, secant, and cosecant. Okay? State the period of the function. Period equals 2 pi divided by b, so pi over 2. 2 pi divided by 1/4, so 8 pi. Find the zeros in the vertical asymptotes. Well, the vertical asymptotes, x equals -1, and the zeros, x equals, this is the vertical asymptote, the 0, x equals -1. The vertical asymptote, x equals -2, x equals 3, because that's what the denominator, and it's still x equals -1. Tell whether it's odd, even, or neither. Even. Okay? So hopefully remember these. There we go. Well, you learn about the tangent function, cotangent function, secant, and cosecant function, and why this will give us functions remaining of the trig ratios. Alright, the asymptotes of the tangent function. Okay, so let's remember. Based on the unit circle, we learned tangent of the angle is equal to sine of the angle divided by cosine. So the asymptotes are going to be where cosine is equal to 0. So if you think about that, we're going to have, so remember the period of tangent, we're just going to do standard, so pi over 2, pi, 3 pi over 2, 2 pi, and then negative pi, negative 2 pi. Well, cosine is 0 at pi over 2, or pi over 2 and 3 pi over 2. So and it's also at the negatives. So if you have a period that's stretched or shrunk or movement going on, you have to figure out what would make them equal pi over 2, negative pi, and then, so now what we look at, when we start at 0, doesn't it slowly go up? And when you go backwards, it slowly goes down? That's what it's going to be for all of these. So there's the basic tangent function. And it's still going to be the same thing for A, B, X, A, B, H, K, or C, D, whatever you want to call them. Okay? The zeros of the tangent function. Well, we found those already too. So let's go. So the zeros, remember? The zeros were 0, pi, negative 2 pi, 2 pi. Okay? The asymptotes of the cotangent function. Probably going to have to find the zeros too, but cotangent, well, remember cotangent then is cosine over sine. So where is sine equal to 0? Well, So we put the asymptotes where sine is equal to 0. So sine equals 0 at 0, pi, and 2 pi. So negative pi and negative 2 pi. You can check the graphs of these in your calculator. You just have to make sure that you are in degree mode, or radian mode, I'm sorry, radian mode, not degrees. So it's going to look very, very similar to the other one. Now the zeros as well, which we're going to need to find. But it's going to look very similar to the tangent, except it's the inverse. So it starts high and goes low. So there's a 0 at pi over 2. There's a 0 at 3 pi over 2. Negative pi over 2. Okay. So there we go. Zeros, that's what we just found. So the secant function. Okay. Secant is the inverse of cosine. So think about this as graphing 1 over cosine. So we're making our standard scale right now. See, on these, doesn't cosine have a maximum of 1? So I'm going to do something. Isn't this what cosine would be? There's cosine function, right? Now, 1 over cosine. Where's the cosine equal to 0 at? That's what we need to look at first. Because everywhere there's a 0 there, there's going to be the vertical asymptotes. Okay? Now, so here's the thing. Anytime you see this, think about these. What happens is, for the secant, what happens at the cosine maximum value, you just make a parabola. That goes up. So there is the secant one. Okay? So the points you need to think about, the maximums and the zeros and the minimums. You don't need to graph the cosine graph, but there's how it's the inverse. Because look, if you think about this, I do 1 divided by that, it flips it over that maximum value. Those would match up, okay? So if we think about cosecant, Isn't cosecant 1 over sine? So if we think about this here, where are the zeros at for the sine function? Well, it starts at a 0. Pi. 2 pi. Negative pi. Negative 2 pi. Where are the maximum values at for the sine function? Oh, hold on. And then it's the same thing here, guys. You're going to open up, open down, open up, open down. So they're very similar, much like sine and cosine are very similar. Okay? Alright. Basic trig functions. This is just something that you can look at, copy them down, understand. Now, these are for the basic ones, the range and domain. If we add an amplitude and things, those change. Okay. All right, I'll see you guys tomorrow.